lesson 2.2 is all about limits that are involving infinity. We're going to look at different things. One, limits whose answer could be infinity or negative infinity. And then we're going to also look at limits as x approaches infinity and limits as x approaches negative infinity. The first thing we're going to need to do is go back and revisit our graph from the other day. Remember our first lesson, we briefly looked at the graph of y equals 1 over x. And we said that that graph looked like this, where we had these asymptotes along the x and y axis. And we said, what happens if we do the limit as x approaches 0 from the left? If I look at the left-hand side of 0, coming this way, my graph is going down towards negative infinity. And so that was negative infinity. If we look at the limit as x approaches 0 from the right, so now looking here, so as we're going towards 0 from the right, we stitch the graph or follow along the graph. We saw it going up towards positive infinity. So we said that was positive infinity or just infinity. Then we also looked to see what happened as we let x approach infinity. We just kept letting x get bigger and bigger. Well, as x approaches infinity, now we're going up this direction. The graph is actually dropping down towards 0. We're flattening out towards the axis. And then if we do the limit as x approaches negative infinity, so now we're looking over here, letting the x's go big this way, then what's going to happen is the graph is coming up towards 0. It's still flattening out towards the axis. So we said that that limit was also 0. Now, what I want to do is take a minute to look at this with a calculator and look at it numerically rather than just graphically. So if I look at it numerically, here's what's going to happen. Let's say I take 1 over 100. Just look at what answer I get. So that's a small number. It's 100. Take 1 over 1,000. Notice that it's getting smaller. 1 over, let's just put a whole bunch of zeros. Okay, now we've got 1 times 10 to the negative 7th. That's even a smaller number. So as we're doing 1 over increasingly larger numbers, our answers are turning out to be increasingly small. So as x is approaching infinity, as these numbers are getting big, the answers are actually getting very small. The answers are approaching 0. Okay. Well, what would happen if we change that just a little bit to 1 over negative 100? Well, we're still getting a small number. It just happens to be a small negative number. Let's get this stuff off here. And if I did 1 over negative 1, let's throw in a bunch of zeros, we're still getting a small number, so that keeps getting closer and closer to 0. So as I do 1 over a big number, my answer keeps coming out small. That is a really important concept. If we have 1 over big, our answer turns out to be little, which we're going to call that 0. Okay? Now, what if we do 1 over little? So like 1 divided by 0.1. That was 10. 1 divided by 0.01. 100. 1 divided by whole bunch of zeros and a 1. Now what we're noticing, or should be noticing, is that as we divide by increasingly smaller values, our answers are getting bigger. What if we did that with negative numbers? So let's do 1 divided by negative 0.1. We're going to get negative 10. 1 divided by negative 0.01. Or 1 divided by negative bunch of zeros there. And again, what we're saying is And as these values are getting smaller, our answers are actually getting bigger in absolute value, although they're negative numbers. So we want to kind of consider those big negative numbers. Okay, so then let's kind of summarize that. If we have 1 over little, we're going to get a big answer. Now, we have to check the sign. The answer is going to be infinity. It's going to be positive infinity or negative infinity. And that's really going to depend on what kinds of numbers you're dividing. If you've got positive numbers and negative numbers being divided. Okay? So let's kind of now apply that to some limits. Let's say we were trying to find the limit as x approaches infinity for 4x plus 1 over 3x squared minus 5. All right, so if we put infinity in here, and remember infinity is not a number, it's a concept, so we really can't substitute that in. And you also have to kind of keep in mind that when I talk about big numbers, I'm not talking about like a million or a billion. I'm talking about numbers with millions and billions of digits. All right, so if I put those in here, here's what's going to happen. I'm going to take 4 times that, and that's going to get bigger. But on the bottom, I'm going to take that huge number, and I'm going to square it. So now it is like monstrous, and we've divided and multiplied it by 3. Well, if I look at this plus 1 and minus 5 isn't really going to have any effect on the size of the answer. If you have a big number and then you add 1, it's still huge. And if you take this huge number and square it, multiply 3 and subtract 5, that minus 5 isn't going to make much difference in the answer. So what we can do is, let's just kind of ignore this part. The only part that's really important are these highest powers in each one of these, in the numerator and denominator. So think of this as simplifying down to 4x over 3x squared. Now, algebraically, we should realize we could cancel out an x in the top and the bottom and get 4 over 3x squared. Then let's think about what would happen if we took a really big number and substituted it into this. Well, the top's going to stay 4, but the bottom's going to be huge and positive. Okay, we'll put approaching infinity. So what we have is 4 over a big number. Well, we already said previously that 1 over a big number is little. Well, 4 over a big number would also be little, because that would be like 4 times 0. So that would end up being 0. I want to go back for just a second and talk about at the very beginning of this. I said if we substituted in infinity, and remember infinity is not a number, but if we put infinity in here, notice that you get infinity on the top over infinity on the bottom. That's another one of those indeterminate forms that we talked about before. We've talked about 0 over 0, and now we've talked about infinity over infinity. And again, what those mean is you just can't find the limit in this form. You're going to have to do something different to find the limit. Now, I do want to point out to you, technically, this is the way you're supposed to solve these problems. We're actually kind of doing this as a shortcut. So let me look at this problem one more time. All right, so here's the deal. What you're supposed to do is if you put infinity in here and you get infinity over infinity, then what you're supposed to do is take that entire problem, find the highest power of x, and divide everything in that problem by that power. So in this case, the highest power of x would be an x squared. So what we're going to do then is divide everything by an x squared. So we take 4x over x squared plus 1 over x squared. 3x squared over x squared minus 5 over x squared. Now that would actually simplify to 4 over x plus 1 over x squared. And then 3 minus 5 over x squared. And now we're supposed to do our limit as x approaches infinity. Well, here we're going to have 4 over big, which we said was little. That's going to be 4 over big, which is little. That's 0. Plus, that's 1 over big squared. So that's 1 over big, which would still be 0. The 3 is not going to change. That's just 3. Minus And then this is going to be 5 over big squared, which would be little. So what we get is 0 over 3, which is 0. And if we go back, I can see that we did the same sort of idea here and came up with an answer of 0. Just a much quicker way to do that. Okay. All right, let's look at another one. This time, let's look at something like this. The limit as x approaches infinity for 5x cubed minus 7x squared plus 3x minus 1, all of that over 2x squared plus 4x minus 3. Okay. So again, because we're approaching such numbers that are huge, when I raise them to powers, anything after that highest power is really not going to affect the answer much. Okay, it's like having $1 million and I give you 50 cents. It just doesn't really affect your life much. So what we're going to do is we'll just look at the highest powers then. 5x cubed over 2x squared. Well, we could simplify that. And we would have 5x over 2. But now if we put infinity in here, we get 5 times infinity, that's big. That's going towards infinity, divided by 2. But monstrously big numbers divided by 2 are still monstrously big. So that's still going towards infinity. So in that case, the answer would be infinity. All right, one more like that. Let's go ahead and look at something like the limit as x approaches infinity of 3x squared minus 4x plus 1 over 5x squared plus 2x minus 4. So again, let's look at just our highest powers, kind of focus on those. So we've got a 3x squared and a 5x squared. But now our x squareds would cancel and just leave me with 3/5. And that's my answer to the limit. Now if you notice, we've actually looked at 3 different things here. We've looked at what happens when the top power is the biggest power, what happens when the bottom power is the biggest power, and then in this case where they have the same highest exponent, they were both x squareds. So let's kind of summarize what's going to happen here. If you're doing a limit, and this only applies as x approaches infinity, if the top power is bigger than the bottom power, so like you have an x to the 4th over an x cubed, or an x to the 5th over an x, and what's going to happen is your limit as x approaches infinity will be infinity. Because what happens is your fraction has a whole lot bigger top than it does bottom. And think about just numerically what happens if your fraction has a bigger numerator than denominator. The answer is big. What if I do the limit as x approaches infinity again? But this time, the bottom power is the bigger one. So if the bottom power is greater than the top power. So again, we're talking about a fraction whose denominator is so much bigger than its numerator. So if you think about a fraction like that, those are all small numbers, like 4 over a billion. So that limit is going to be 0. And then the last thing that happens is, what if the top power and the bottom power are the same? So you got x squareds and x squareds, like that last problem. Then what's going to happen is, the limit as x approaches infinity is going to be some fraction a over b, where a and b are your leading coefficients. So if you've got them in standard form, where we've got them in decreasing order, then a and b are your leading coefficients of your numerator and your denominator. Those are 3 really, hope you've got how important I think this is, important rules you need to remember. Top power bigger than the bottom power, it's going to be infinity. Bottom power is the bigger one, it's 0. If they're the same power, the limit's going to end up being a fraction. Now, we need to look at one more thing with this. We talked about the other day what happens when you get 0 over 0. So if you're evaluating a limit, something like this, the limit as x approaches, let's say, 4 of x squared plus 5x plus 4 over x squared minus 16. If you put 4 in there, whoops, that's not going to work. Let's make that x squared minus 5x plus 4. If I put 4 in there, I'm going to get 4 squared minus 5 times 4 plus 4 over 4 squared minus 16. That gives me 0 over 0. And our rule was that when we get 0 over 0, we try to factor and see what happens. So we got x minus 4, x minus 1, x minus 4, x plus 4. Those canceled. And then we just went back and put in 4 to what was left. So if I put 4 in, I get 4 minus 1 over 4 plus 4. So that's 3 over 8. And my answer was 3/8. Now, the last thing we need to talk about is what happens if you're not getting 0 over 0, but you're getting something over 0, like 5 over 0 or some number over 0. So let's look at an example of that. What if I ask you to find the limit as x approaches 2 for x over x minus 2? Well, if I start with substituting in, I get 2 over 0. That's undefined. Well, what happens is, in this case, that does not necessarily mean you don't have a limit. It means I'm going to have to do some algebra with this. All right, if you remember, we talked about numbers that make the denominator 0 could either make it have an asymptote or a hole in the graph. Since nothing is factoring and canceling here, you've got an asymptote. Well, when you're approaching an asymptote, you have to check a left and a right-hand limit. So we're going to see what happens as we approach 2 from the left and 2 from the right. If you're getting a number over 0, you have to break it up into 2 problems, a left and a right-hand limit. So let's do that. All right, so let's think about this for a minute. If I put in numbers from the left of 2, so you're looking at like 1.9, 1.999. Well, the top, if I substitute in, is just going to be a number close to 2. So that's approaching 2. But then what's happening here on the bottom? Well, we've got a number a little bit less than 9, and we're subtracting, or a little bit less than 2, sorry, and we're subtracting 2 from it. So if we took like 1.9 and subtracted 2, we'd end up with a little bit of negative stuff. All right. So if I've got a little bit of negative stuff, that means I've got 2 over little, and we talked about that was big. So that answer is big. But we've got a positive divided by a negative, so that answer would be negative infinity. Now down on the second part of this limit, we put 2 in and we get 2. But this time we've got numbers a little bit bigger than 2 because we're going from the right of 2. So we're using like 2.1. Well, 2.1 minus 2 would be a little bit of positive stuff. So we'll say that's a little positive. But a number over little is big. And then I have a positive divided by a positive, and that's positive. Now, really important thing. The left-hand limit is going towards negative infinity. The right-hand limit is going towards positive infinity. So that tells me that my original limit does not exist. That the limit as x approaches 2 doesn't exist. Graphically, here's what's happening. Okay, we've got an asymptote over here at 2. Okay. And as we approach 2 from the left, the graph is going down. So wherever this is at, it's going down like this. As we approach 2 from the right, so we're coming this way, it's going up. So what happens is those asymptotes, at the asymptote, you're headed 2 different directions. So then the limit would not exist. Okay. Let's look at one that's a little different than that. What if I did something like this? The limit as x approaches 4 from the left, the 5 over x minus 4. Now notice this time I'm only asking you about the left-hand side of 4. So we're looking at 3.9, 3.99. So we have 5 over, numbers a little less than 4 minus 4 would give me a little bit of negative stuff. So we have a little negative on the bottom. And 5 over a little bit of negative, or 5 over little, is big. But a positive divided by a negative would be negative. So the left-hand side of that should be going towards negative infinity. Okay? One more. We'll wrap up with this. What's the limit as x approaches 0, 1 over x squared? All right, so if we substitute in, we're going to get 1 over 0. So that tells me I've got to do a left and a right-hand limit. Notice up on this problem I didn't do both because it told me I only wanted the left-hand side. Since this doesn't say from the left or right, you have to do both. So do the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. So if I put numbers that are a little less than 0 in here, so like negative 0.1, I'm going to get 1 over, but a little negative number squared, that's a little negative because it's to the left of 0. A little negative number squared is actually now a little positive number. 1 over little is big. And a positive 1 divided by a positive would be positive. If I put in numbers a little bit bigger than 0, so little positive numbers, well, a little positive number squared is still a little bit of positive. And 1 over little is big. And a positive divided by a positive would be positive. So this is a case where you've got an asymptote, but the limit actually does exist. It's approaching infinity. And again, graphically, here's what's happening. As x approaches 0 from the left, the graph's going up. And as x approaches 0 from the right, the graph is going up. So it looks more like that. One thing I want to stress before we finish up here, guys, you have got to learn the 3 rules back here on the powers when you're approaching infinity. These are really common AP questions where they'll just give you a quick, you should be able to do in less than 30 seconds, a quick limit where you just have to know these rules of powers. When the top is the bigger power, it's infinity. When the bottom's the bigger power, it's 0. When they're the same power, you just make a fraction out of the leading coefficients. You really, really have to learn those rules because those are going to be really important for the AP test.